Good afternoon, everyone, and welcome to the Open Source in Fintech Meetup. My name's Claire Cox. I work for Scott Logic, and I'm one of the co-organisers of the Meetup, which we run in partnership with Finos, the Financial Services Open Source Foundation. I hope everyone's keeping well. I can't quite believe that we've been running these events online for 12 months now. For anyone who hasn't joined one of the meetups before, these are usually run as physical events in London, Edinburgh and Bristol, and we're going to be adding Leeds to the mix later this year too. Now, we're very much looking forward to welcoming everybody back and seeing you face to face as soon as we can safely do so. And when we do get back to normal, the plan is to live stream our events so that you'll still have a choice over whether or not to watch it online or attend in person. So if you haven't already joined one of the meetup groups, I'll put the links in the chat box so that you can join your nearest group and be notified when we schedule future events. So a couple of housekeeping points before we get going. If you'd like a copy of the slides, just send me a message in the chat box and I'd be happy to send you them. I'll also add my email to the final slide so that you can email me after the event if you want them as well. Now, if you want to ask a question, just pop it into the question box and we'll take as many as we can at the end. But before we get going, let me just tell you a bit about today's speaker. Andrew Carr is a solution architect at Scott Logic and specialises in data engineering. He first caught the data engineering bug in 2001 when looking at solutions to process large volumes of call data records, and has been involved with many of the innovative technologies in processing, data storage and messaging ever since. He's worked for and with many clients in financial services and the public sector around low latency streaming, large scale processing, storage and messaging, and has written many blogs on the subject. So if you're interested in reading more, just head over to the blog section on the Scott Logic website. But without further ado, let me pass you over to your speaker, Andrew Carr.
Hello, welcome everyone. I hope you can all hear me well. So I'm going to cover the subject of data meshes and look at what open source software you can use to create your own data mesh. I just want to say at the outset, at the beginning of this presentation, that unfortunately data mesh is such a big topic that I've probably tried to cram too much into this presentation. I will try and rush through it as quickly as possible, and I'll give you a little bit of an overview of what I'm going to chat through just here, and also the points I'm going to make. I will probably do it in just under half an hour, which will give you, I think, about 15 minutes for questions. But I guess just in general, there's way too much to go through in one presentation. So if you've got any more questions, reach out to me. I love talking about this stuff. So first of all, I'll go through the history of data lakes, some of the challenges with data lakes, which I'm sure many of you will know about. I'll talk a little bit about a data mesh, and I will talk a little bit about some of the open source software that can be used to get there. And I'm also going to talk about some of the pitfalls, give a word of warning, and then wrap up. During the presentation, I am going to make a few arguments as we go along, though. I'm going to talk about why I believe data lakes became centralized. By the way, there's probably too many words on these slides, and I generally like to reduce them and have as few words as possible. This is probably one of the worst offending slides. The reason for this is there's a lot of stuff to try and get across, so I'm going to try and be as succinct as I can in the rest of the slides. Anyway, yeah, I'm going to argue why I believe data lakes became centralized, and changes that are happening now to them, that the technology is more aligning with general software development technology. And I'm also going to argue that many of these complex open source solutions are now simplified, being SaaS and PaaS, and therefore some of the complexity is taken away, especially when they're provided by cloud providers. I guess due to these changes in technology, plus looking back on how successful we've perceived data lakes to be, people have started to look for more decentralized approaches. And I guess the data mesh is one of these much more decentralized approaches. I'm also going to talk about going cloud first, and there's some great tools, including open source and not open source in in the cloud that can help you get there. And then also talk about, regardless of cloud, what other great open source tools are out there to help you get there, because recognize, certainly in financial services, that cloud isn't always possible. And I'm going to give you a very clear word of warning that tech won't get there alone. When talking about data meshes, the data ownership as a product, so thinking of data as a product, is absolutely key to the success of using a data mesh approach. So quick history on data lakes. So data lakes became centralized. I think one of the key reasons was that tech was so different to the tech we had at the time, and I'm going to quickly chat through a little bit about that, that you needed specialists, and there weren't many of them. So what happened was a lot of organizations naturally tried to centralize this, and the fact that data lakes could hold all of your data, it lended itself well to. Now, whether that was such a good idea when we first all tried it is another question. And I guess looking back on some of the history gives you some of the reasons why it was centralized. It all started way back when Google came out with a couple of white papers. One, their Google filing system, which was published in 2003, and then a second white paper about Mapreduce, which was simplified data processing on large clusters. And I guess two of the big outcomes from that really is these common large virtual filing systems such as S3 and HDFS, and obviously the Google filing system, and cluster processing. Mapreduce is a technique that I think everyone has heard of now. So I guess in terms of the filing system, splitting up files into segments and being able to work on those segments separately and then pulling the answer together was one of the key innovations that it really allowed scale of processing to happen really quickly. And actually, if you look at the design, it works super well for search engines. If you think back to what Google was trying to do when it came out with those white papers, it really was looking at doing search engines en masse and do crawling en masse. And actually, you know, doing Mapreduce and large virtual filing systems worked really, really well for that. So raw data was very common because the raw data was the websites. And Hadoop basically, when it came out, processed everything as file types. So everything was naturally files. Mapreduce as a concept, obviously, I think everyone knows about it now, but essentially it's processing things at a large scale. It really is the way to break down a problem where you're processing one thing. If it's one file, you could break it into 5 sections. And basically what you do is you run the same process on each of those 5 sections of the file, and then you bring the answer together. It works very well for some types of processing. So searching is a good example. Summations, certain types of mathematical calculations. It doesn't work well for other types of certain calculations. So a good example is weather simulations, where each area of the calculation actually impacts another area as well. And so physics and those types of things don't work well for, and simply don't work for that Mapreduce way of breaking things down. But actually, a lot of problems do break down into Mapreduce quite easily. So I guess the key, though, was at the time, Mapreduce was very different programmatically to what had gone before. And again, this was part of the reason why a lot of teams ended up getting specialists who could write Mapreduce jobs. So again, yeah, just to kind of summarize, I guess, what tended to happen is you had business-aligned IT teams. They would have their own databases, maybe even a data warehouse, and they would chuck the data over to a centralized data lake team who would own that data. And I guess the centralized data lake team would therefore have a common view of the data across all the systems. Now, this had some advantages that you could start joining data between different systems, but definitely had some downsides as well, in that they could, well, basically, you would need to be very careful to make sure that you didn't break Chinese walls by people crossing data that they shouldn't be allowed to cross, but also permission and access, what can be used for what, became real issues with this type of solution. But looking beyond that as well, there were very common problems with it, that the data lake contained source system idiosyncrasies. So if a system had stored something in a particular way which was known to that source system, once it was dumped into the data lake, the people using the data lake wouldn't understand any source system idiosyncrasies, and that had a real created real challenges for the data scientists using the data lake. also data quality became a very particular issue. And I guess one of the big drivers with a data mesh is that the source system, the business aligned IT teams or the business themselves very much own data as a product. And the reason for that is that they are very much responsible for the data quality. And that's, I guess, one of the big difference between the old data mesh approach and, sorry, data lake approach and the data mesh approach. So we talked about the centralization, we talked about the tools being specialist, we talked about the quality of data lakes being variable, and this has resulted in the results you tended to find from large data lake projects has often been very mixed. There's some real success stories out there, but equally there's been some very visible and public failures. So one of the other challenges, as well as writing the software, being difficult, one of the other challenges, some of this software, certainly the cluster software, has been very complex to manage. And I always like to give the example of Kafka, which is just one of the pieces of software that is typically used in these, and a very popular one at that for messaging. Kafka has hundreds of configuration variables. So if you're managing your own cluster, it's incredibly complex. I possibly think it has over 500 configuration variables, and it seems to be getting more complex as it goes along. Now, that's just one piece of software. That's, you know, talking about Kafka as a messaging thing. You also got the processing software, so you've got Spark, Flink, Storm, Hadoop, and then you've also got storage as well. And when you're looking at different teams configuring these clusters, setting them up and managing them, with all this complexity, you really have been looking at specialist teams. And as I said, coding these early technologies was often different to normal development as well. And here's a good example of early Spark code. This is still valid Spark code now, but this is when people used to use RDDs for Spark. And this was at the time very different to how people were typically doing coding, although it is very functional in nature. I won't linger on this, but it's clearly different to how OO Java code at the time was working. So as we've discussed, data lakes have become centralized because the tech was so different. You needed specialists. There weren't many, so people tried to centralize the function, but that is changing. And change number one is the technology is aligning more with general software development, and I think that's a good thing. So if we now look back at Spark, and in particular we look at a Spark SQL statement, this is clearly a lot more readable than the previous code, although the previous code did something different. Most people will have used SQL, and actually a lot of the streaming and batch-based technologies are starting to introduce SQL languages into their technology and really mature that, so that developing on it is a lot more similar to how technologies have been in the past. And I think this kind of ease of transition now between general software development and some of these technologies now is making it so that you don't need so many specialists to use these systems. And just to give you an example, and this is just a few, but there's a lot more. These are technologies that have introduced SQL or SQL, very similar syntax to their technologies, and enable you to do things pretty much, if you understand SQL, you can get up and running really, really quickly. So on the flip side, as well as these streaming technologies introducing SQL and idiosyncrasies that we already know, conversely, some of the technologies and approaches that have been introduced with Hadoop, Mapreduce, etc., have actually started making its way back into languages. So if you look at the modern versions of Java, there's now map, flat map, and all the technologies, all the approaches that you tend to see in Apache Spark and some of the other approaches as well, which means that developers, that kind of approach is generally pushing its way back into the languages as well, which is further reducing the difference. Change number two, most of these complex open source solutions are now available as a service. So as a service, it reduces the complexity because you don't have to manage the cluster yourself. And this is a huge speed increase in terms of rolling out your own Hadoop cluster, configuring it yourself, or just using it as a service. And we talked about languages introducing, I guess, streaming. So looking back, changes in technology plus looking back on how successful we perceive data lakes to be, people are starting to look for decentralized approaches. And data mesh, I think, is the one, I guess, talked about most of all, and really is the kind of big change to how a lot of people are approaching this. So a data mesh, for those on the call who don't know what it is, essentially it's a very decentralized approach. Instead of there being one data lake team where the business aligned IT teams fire their data over to and it's pumped into a centralized data lake, the business aligned IT teams keep the data and they are responsible for owning the data as a product. And what they do is they're the ones that provide APIs to provide that data to other teams, and they can store the data in data warehouses or their own local data lake. But essentially, there is no centralized data lake. And when people want to join data between the different teams, they use APIs that connect directly to the teams themselves. And there's other key approaches as well, which is very much a domain-driven design and bounded context. So essentially, instead of trying to create this unified data model across your whole business, what you do is each domain owns a data model in your team. And if you want to start crossing data sets with other data sets, you have parts or key objects which basically cross over. So you work out how those federated identities work, and so then you make sure that these data sets connect to those federated identities, and that's how you can then cross data between them. And the teams should work out how to share that data once they own it as a product. Now, there's a whole bunch of open source technologies that are needed to help you with that approach. You essentially need some form of self-service platform. You need some software to help you treat data as a product. And this presentation, I guess, isn't long enough to talk about what does treating data as a product mean. But essentially, in a nutshell, it's owning the data itself. So the team that are responsible for the system also own the quality of the data. And the data itself is a product. So you can serve it via APIs, but as a team, you're responsible for that data quality. And it means that if there's something wrong with that data, you own it, essentially. Now, that means that you need some screens to measure the data quality, but also change and maintain that data when it goes out of date and when it's wrong. Now, depending on whether you want the business to do that or the IT team to do that, there might be varying degrees of ease of use of the software that you would need to be involved. So we talked about data use tools which are closer to the skills of the IT team. So that should help the IT team manage this technology and write new services for it. And we also need API tools to enable data sharing. Once the data is a product, you then need to share it with the rest of the organization and tools to enable you to do that. So before I go through these tools, I'm going to chat briefly about some of these tools. This is absolutely not an exhaustive list of all the tools. There's simply hundreds of tools out there, and it would take way longer than half an hour to go through some of the tools. So what I've done is gone through just a few of the tools at the high level and some of the tools that are commonly used in some of this space. I'm also going to talk about some of the maturity of some of the tools as well, because I believe that when you're moving from a data lake approach where you've had specialists looking after these tools to a more decentralized approach where you've got less specialized people using these tools, by definition, the tools need to be easier to use and a lot easier to get up and running. Now, in terms of going cloud first or not, there is a big distinction whether you go down this data mesh route via the cloud or whether you do it using your own data servers and services that you write on that. And really the big differences are speed, because it really is very quick now to use the cloud. And one of the key reasons for that, as we'll chat about in a second, is the fact that a lot of these tools in the cloud are already integrated together. So using them, you get a huge leg up in terms of using them quickly. A word of caution, it's not always cheaper to go to cloud though, and it can be more costly. So watch especially data transfer costs. But again, as we talked about, the cloud first is definitely highly integrated. Just going to bring up argument 3. Going cloud first, there are some great tools, open source and not, which can help you get there quickly. So if we look at AWS, there's a number of different areas which we discussed that you need tools to help you in. And this is not an exhaustive list, by the way. You probably need a lot more tools than this, but this is kind of some key tools that you would need to use. So for the self-service platform, you could do a lot better than using AWS Glue, which is a great tool for doing data ingestion really quickly and integration. It isn't open source, but it does allow you to kind of get to that bit really quickly. In terms of treating data as a product, or I guess in terms of processing, lineage, data management, there's Apache Atlas, which we'll chat about in a bit, and Amazon EMR as well, which includes Spark, Flink, Storm, all the processing tools that you need as well. And AWS also provide a tool called AWS DQ, I believe it's pronounced, which is their open source data quality tool. And then in terms of enabling tools to use data as a product, i.e. providing access to it, the Amazon API Gateway and associated tools is great to be able to provide that access and to manage that for you. I'm not going to go through them all. I just selected a bunch of tools that are also available for GCP or Google Cloud. Again, a lot of these tools are available on the different cloud providers. I just happened to pick a bunch that were on G-Cloud just to give you an example. And to be honest, the same is true on Azure as well. Yeah, all cloud providers, they have similar tooling, different levels of maturity. In terms of open sourceness, it is worth looking at and considering that actually the distinction between open source and not open source when it's used as a service is a really interesting distinction, in that with open source often you obviously know the code, but when it's as a service and you get charged for it, it's certainly not free to use anyway, because you're still paying for the service than one of their standard services that they provide. And then in the non-cloud, there are lots of open source tools. I could list many more, but here's just a bunch that could potentially get you started. It is worth noting though, like I said with these open source tools, that if you do them outside of the cloud, there is a lot more work to be done, both in terms of integrating these tools and configuring them. If you just take one thing alone, say if you're talking about the Hadoop ecosystem, so Apache Spark, Apache Flink, HDFS, Kafka, etc. Just getting a whole bunch of open source tools from the Hadoop ecosystem to all run with each other and align all the different versions is a huge task. So at the very least, if you don't go down the route of using as a service, I would definitely recommend you go down one of the distributions like Cloudera just to get you up and running. Otherwise, you will spend ages getting everything configured and working properly. Now, in terms of making a big data mesh, once you're using like a distribution and you want to put more software on that or integrate it all just to make it a bit more smoother and build your self-service platform, I do recommend using as much distributions as possible if you're not going in the cloud, and you will need to write a lot of gluing code just to glue everything together and give you your self-service platform that will work in your organization. And again, certainly on the API side, there's quite a few different open source tools around that. And we could spend a whole presentation chatting about API tools, their maturity and the pitfalls and advantages to them, but I won't go through them now. I also, I guess want to say that, there are some great open source tools out there, but really the maturity of the tools integrated together is a challenge compared to the cloud providers. So there's a big step up. In terms of the open source tools themselves, I'll go through some of them quickly. Most of you are probably aware of a lot of these on the call. Apache Spark and Flink, absolutely great processing engines. I'm a firm believer in the Apache Beam project that Google have put together, where they're basically trying to produce an API that hides the processing engine behind it. And so if it comes to pass and everyone adopts the Apache Beam approach, essentially Apache Beam could also almost become the SQL standard for processing engines in a way. Not as an SQL standard, but similar the way that SQL became the way that you use databases. That way, what you do is you write code to Apache Beam and you use a different runner behind it, whether it's Apache Flink runner, an Apache Spark runner, or Google Cloudflow. And then what happens is you can change the runner and the code stays exactly the same. So interesting movement there. Messaging, I suspect I don't need to tell many people about Kafka on this call. Watching the popularity of Kafka over the last 4 years has been fantastic, but it has become a very mature messaging tool. We talked briefly about API management. The one thing I would say about that is be careful how you use these tools. I've seen a lot of projects go wrong and be quite hampered when they didn't understand the architectural implications of using some of these tools. So they can be amazing and they can give you a huge leg up, but do go into them with your eyes open. Otherwise, you can get quite hamstrung of how your architecture works. In terms of data ingestion, there's a number of good tools out there. StreamSets is one I just happened to pick to chat about now. It's a great drag and drop ingestion engine. It's based on Apache Spark and Kafka, and it's a good open source way to get your ingestion engine up and running quickly. In terms of data lineage, there's Apache Atlas. It's an open source tool with a data dictionary and does data lineage. In terms of data quality, there is an open source version of Talons, which is a bit restricted, but still, I guess it's probably the de facto data quality tool in the industry. The big question, though, when looking at a data mesh is it good enough and easy enough to be used by the business? Now, I'm not going to try and answer that question here. It very much depends on the business users, but just giving you a look on the diagram, on the picture, on the screen, you can probably form a bit of a view on in your own mind about that. And a huge topic which absolutely haven't got time to talk about in this presentation is federated identity management. And this is huge when thinking about a data mesh. And it really covers how you're going to link data sets between data domains. And so this is probably more falls down into kind of organization and how you would organize this as a business to make sure that you get federated identity management, and probably a little bit less about the tools that you use. So I guess I'm rushing through just so I can finish in the last 3 minutes, but essentially, I hope I've given you a bit of an idea that there are some amazing open source tools out there. I hope I've managed to get across that the state of maturity of them is very variable. Some of them are quite mature now, but plugging them all together, if you did it outside of the cloud providers, you would be writing a lot of glue code just to get the whole thing seamlessly up and running. I would recommend going cloud first, therefore, if you can do. One of the big challenges with this, certainly if you want to go down the data mesh route, is if you need to treat data as a product. And if you do that, and the business users are going to own the data, you may be writing a lot of code around the data management side so the users can maintain the quality of that data. So yeah, I guess that brings me on to my final argument. As I've mentioned, I don't think tech will get you there on its own. You really do need to think about how data as a product will work. And I've certainly talked to a lot of clients where they're looking at making, certainly within their own teams anyway, and even regardless of this movement, the business own the quality of the data to really help them get more use and more value out of that data. So I think it's a good movement anyway. So to summarize, the data lake approach has had mixed results, some successful, there's been some failures as well. History shows us that the original approach made sense at the time. The changes that have come about, especially in the technology side, are enabling a new approach, a data mesh, and that's come from both the technology being easier to use, more like the other technologies we've got, but also the fact that the cloud providers mean that the technologies are easier to get up and running. You don't have to manage all these complex clusters. A data mesh does require a level of integration of tools and ease of use to really make it a reality. And although these tools are maturing of the time, cloud first will save you a lot of time in getting there. And I guess my last point, just before I hand you over to Claire, is this really is way too much to cover in one presentation. So I do apologize if I've skimmed over everything, but I just wanted to give you a flavor of this. And if you're interested, I'm always happy to talk more. So over to Claire.
Thanks, Andrew. Wow, that was a real whistle-stop tour, wasn't it? There was so much in there. I can see why you put so much on the slides now. If anybody does want a copy, like I say, just ping me a note in the chat box or send me an email. If you want to move on to that next slide, Andrew, I'm just going to give everyone a couple of minutes to get their questions in. I can see that a couple of people have put them in the chat box. Do use the question box if you can. Just to say, if you want more information on this topic, Andrew is in the process of writing a white paper about data mesh. We've got a short survey that comes up at the end. So if you fill in the survey, one of the questions is, would you like a copy of the white paper? So that's how you can request it. You can also drop me an email. My email is at the bottom there. Andrew has very kindly provided his email. If you've got any questions, I know he'd be happy to chat after the event. Also, just to mention that Andrew is doing another presentation on the 3rd of March with Charlie Boundy, who's the head of data science at DWP. They're going to be talking about data mesh, what's different about it, what it means to DWP, and how you can approach it yourselves. So there's the link to join there, the bit.ly link, data mesh DWP. So hopefully you can join us for that too. Let's have a look at some of the questions. Are you ready for a question, Andrew? You got your breath back?
Fire away.
Great stuff. Right, here's one. I don't see anything for mastering data. Are there any good open source tools?
It's a really good question. I think there's a lot of very mature non-open source tools in the market, you know, with some of the big players like Informatica, etc. I don't think, I've certainly not seen any really mature tools in the open source market around that area. And I think that's you know, a really good point. So not that I know of, not large scale mature ones. I'm hoping that the move to a data mesh approach might mean that someone produces one.
Great stuff. Next one. When each department does their own data management, how do you recommend avoiding tool proliferation and redundancy?
So that's a really good question. I think it's best if possible, the platform, so I talked about a platform earlier, the platform is provided to the teams to make their life easier. So I've seen I guess a platform for one organization where what they've done is they basically give you the tooling, so you can upload your data into a central area that will just keep it. And then when you want to process it, you pull it back and you get your own either data lake or you get an instantiation of a local SQL database, and then you manage it yourself. But the tooling gives you those technologies to do it. And so it means that you don't introduce your whole bunch of new tooling. All the teams use the same tooling, but the teams get that data back and then they use that tooling locally. But I think that's a really good question. But I think the key to that is the platform.
Good stuff. Right, next one. You mentioned lots of tools. How mature are they if you wanted to build a self-service platform using these open source tools, not in a cloud provider?
The honest truth is it would be a lot of work. I think the fact that the cloud providers have done it for you does mean it's much, much faster. It really depends on what your requirements are. So if you're going to constrain the requirements, I think there's a bunch of tools you could probably start with. You'd obviously need, if you're going down the route of allowing people to have local data lake type technologies like HDFS, so, you know, pick one of those like HDFS and then say, okay, we're going to let you have a processing engine as well. Apache Spark wouldn't be a bad choice. And then it's really about how they self-service those tools back to themselves. And then you'd need to have a whole bunch of screens that do the data management over those data sets.
Okay, here's another one. I'm trying to keep an eye on the Q&A box and the chat. Here's one in the chat that says, are there any tools for managing or identifying brittleness in a data mesh around data geography and regulation, i.e. in the case of data dependencies?
Yeah, so it's a really, really good question. In terms of data monitoring, I think there's quite a few tools that do that around the edges. I don't think there's any great open source software that does it all. I think you've got a lot of tools like Talons that have kind of open source versions of it that you can use to do bits of it. But it still would require lots of work on your own. So essentially there's nothing out of the box that's open source that you can use to get up and running super quickly. You'd probably have to use some of the open source versions of some of the tools like Talons and write your own components to do stuff like that.
Okay, here's another one for you. How easy is it for business users to use these open source tools for treating data as a product?
I think that's an excellent question. If I'm honest, I think in terms of the open source tools, I think there's a lot of there's a huge gap between where they're at and you know, business users using them. I mean, Talend, which is possibly the most one of the most common data quality tools used on the market in that respect. And if you look at Informatica and some of the competitors as well, they're all quite technical. They're all almost assume that you're a developer level or quite a technical person. I think it's more likely to work is if you write application tools and screens to manage the data is going to be much more successful. And then once the data, you've got the data ready and you're happy for it to be provided by the API, then you know your tools for the API management are the ones that provide that data. But I do think in terms of open source maturity for tools for business users to use, I think they're quite far away from being useful to do it, to be honest.
Okay, and I think this is the last one, unless anybody gets one in quickly. I've got here, what advice do you have to avoid a data swamp?
Yeah, that's a good question. I think our previous approach of just dumping everything into the data lake uncontrolled, I think was the initial approach that everyone took. And then everyone kind of matured that approach of having like a raw area of data and then almost like a kind of matured and verified area of data, where that verified area would be more curated and understood and then almost certified, ready for use. This data mesh approach is essentially doing that again, but you're just pushing it back to the source systems and letting them curate it locally. I very much recommend you go for that curated approach. If you just dump it all in some raw place, you're going to end up with a data swamp. And I guess, you know, I mean, we've not touched on data discovery, and there's a whole bunch of other things you need to do to do data mesh well. I think unfortunately this is such a big topic, but data discovery and making sure that you're curating data that's going in to that data discovery is also key to prevent you getting a data swamp.
Great stuff. I love that we're ending on a swamp. It's all very water themed, isn't it, around data?
Well, it's it's a thing. I think once they came out with that theme, everything related was swamp and lake, etc.
Well, we've covered all of the questions. I've found that massively informative, so thank you, Andrew. So that just leaves me to say thank you to everybody who joined live. We have recorded it, so if you'd like a copy of the recording, we'll send everybody an email tomorrow with a link where you can access that. Hope you can join us for the next one. The next Open Source FinTech Meetup will be in May. And thank you so much, Andrew. Thank you for joining us.
Thank you, everyone, for listening.